right. Chapter 5 review.
Our exam covers 2 chapters, Chapter 4 and Chapter 5. This is an extension, so it's to simplify as a single radical. But in this case, we don't have any radicals, so we're just going to simplify it to a single expression. Here's one thing I see people do that is not allowed. You can't just raise this to the negative 1 and this to the negative 1. That's the same thing as when we have something squared. If it's addition or subtraction, you can't just square each one of these. So you can't just raise these to the negative 1. You want to work from the inside out. So this is going to be 2 plus x to the negative 1 means 1 over x. And this is now to the negative 1 power. There's a couple ways you can do this. To make this to the negative 1, I can do 1 over this right here. But I'm not allowed to just do, again, 2 to the negative 1, this to the negative 1. Or I could get a common denominator. If this had been just a single expression, then I would be allowed to just flip it and come up with to the negative 1. You want to do it that way? So if I want to get a common denominator, I would multiply this term by x over x. So now I would have 2x plus 1 all over x to the negative 1. All I did was I got a common denominator. Now this is just a single expression. It's not 2 terms, it's a single term. So now if I want to raise it to the negative 1, what do I do with it? Just flip it over. And that would be another way of writing it. For number 2, what do I have to do with this kind of a problem? Get a common base. This is 7 to the 1/8. This is 7 squared, so that's 7 to the 4/8. Divided by, this is 7 squared in the 4th root. Think about this. What is this? This is really 7 to the 1/2 divided by 7 to the 1/2. So what's that going to be right there? 1. Anything divided by itself is 1. So these would just be 1, and then I would just be left with 7 to the 1/8. So to write that as a single radical, it would be the 8th root of 7. On number 3, it says simplify to a single radical expression with the denominator rationalized. Remember absolute value. So I want to get this to a single expression. What do we have to do? We have to have a common denominator. So I'm going to multiply this by 3 radical x in the numerator and 3 radical x in the denominator. When I do that, I now have a common denominator. I'm going to have 1 over 3 radical x plus 18. Now here I would have the square root of x squared. The square root of x squared is x, but I have to put absolute value around it because I had an even root and an odd power. So now we have a common denominator, so I can add the 2. 1 plus 18 absolute value of x all over 3 radical x. But it says we can't have the denominator, it has to be rationalized. We can't have it irrational. So I'm going to have to multiply the denominator by radical x and the numerator by radical x. When I do that, I'm going to have 1 times radical x is radical x plus 18x times radical x is just 18x radical x. And then if I have radical x times radical x, that's radical x squared. So that's just going to be 3, what? Absolute value of x. That would be that answer simplified. Yes?
Why did you put the absolute value in?
Why did I or didn't I? Because I had the square root of x squared. So this x value could be a negative number, say it's -3. If I square -3, I get 9. The square root of 9 is positive 3, not negative 3. So I have to use absolute value for that case. Anybody else? All right, so in this problem, I'm trying to get it to a single expression, so I want a common denominator. So I'm going to have to multiply by x to the 2/3 over x to the 2/3. That's going to give me 4 plus, I'm going to have a common denominator now, so it's all going to be over x to the 2/3 because I have a common denominator. What's x to the 1/3 times x to the 2/3? Just x, isn't it? Because I'd have like bases, I'd add the exponents, 3/3 is just 1. And then what do I have to do with this? Get a common, well, I already have a common denominator. I have to rationalize the denominator. What would I multiply this by to rationalize it? X to the 1/3, because I have to get x to the 3/3. So if I do that to the bottom, I also have to do it to the top. So now I'm going to have 4x to the 1/3 plus x times x to the 1/3. Down here I have x to the 3/3. That's just x. Do I need absolute value around this x? No, it's cube root. Doesn't matter. I do, though, need to write this in radical form because it says to use radical form. So to write 4x to the 1/3, that's 4 cube root of x plus this x doesn't need to change, but this is the cube root of x all over x. So this result is the same as that original problem. We're just writing it in a different way. Yeah.
So when rationalizing the denominator, you have to get on the top, and if it's like in the problem for 4 plus x, we have to go to everything.
Yep. Because it has to, because I have this one single value, and if I multiply the bottom by something, I have to multiply the whole numerator by that same value. Everything. If it had been 4 times x, then it would just be 4x, x to the 1/3. But if it's addition, I have to distribute. See, when it's multiplication, you don't distribute, you just multiply the whole thing. So it's different. It's just like this, guys. People always get confused about this. The difference between 4 plus 2 times 3. What's that answer? It's 18, isn't it? Wouldn't it be the same thing if you did this and you did 12 plus 6? Wouldn't that be correct? But what if it had been 4 times 2? What's that answer? 24. Would you distribute this, or would you just do 4 times 2 times 3? This is just 4 times 2 times 3, right? You see the difference? On when it's addition of 2 terms, you have to distribute it. But if it's multiplication, you don't distribute it. You just multiply the 3 numbers, 3 values. Okay, factoring out the GCF. This gets a little confusing, so watch closely. When I'm factoring something out, I always factor out the common factor, the greatest common factor. So what's the greatest common factor for 25, 10, and 15? 5. So I'm going to factor out a 5. When I take out the x, I take out the lowest exponent. So what is the lowest exponent? -1. So I'm going to have to take out 5x to the -1. 25 divided by 5 is just going to be 5. X to the -1 divided by x to the -1 is 1. 10 divided by 5 is 2. X cubed divided by x to the -1. What is that? X to the what, everyone? Mm-hmm. And then what about the next one? We have 15 divided by 5. What's that? It's 3. What is x divided by x to the -1? Everybody see why it's x squared? We subtract those exponents, x squared. Now watch closely when I get this completely simplified. I'm going to have a 5 in the numerator. But I'm going to have this x to the negative 1, that has to go to the denominator. I have to have 2x to the 4th first, because it's my highest exponent, then this term, and then that term. Look again what I did. 5 is not with x to the negative 1. 5 is just to the positive 1. 5 to the first, that's on top. X to the negative 1 goes to the bottom. I put this term first, this second, and this third to put it in descending order. Instead of doing this one, we're going to do this one first. All right, so look at this term and this term. Terms are separated by pluses and minuses. What can I take out as far as 3x and 6x squared? What can I take out? 3x. And then y was my lowest exponent. All right. So I'm doing 3x divided by 3x. That's 1. This divided by this is also 1. You have to write the number 1 there. Then you have to put a plus. 6x squared divided by 3x. That's 2x. And then what's y to the 1/2 divided by y to the negative 1/2? It's just y, isn't it? So look at how this is going to get simplified. 3 is to the first, x is to the first. Those are going to stay on top. This stays on the top. But y to the negative 1/2, that has to go to the bottom. And now I have to rationalize it, because I shouldn't leave it unrationalized. So I'm going to multiply by radical y on top and bottom. And so this is going to be 3x radical y, 1 plus 2xy, over radical y times radical y is radical y squared, which is just y, but I have to use that so that I am. Does it make sense? Think you could do it if it was matching, multiple choice or something? Okay. It's pretty tough.
I gotta look into that.
All right, but you gotta understand the process. I mean, it's tough to get all the way through it, but I mean, the hardest part is probably going from here to here and then just remembering to multiply, you know, that radical to rationalize that denominator. Yeah, no. All right, let's do one a little bit tougher now, guys. This one's tougher. So look at this and look at this. A lot of times when we have these parentheses, it gets confusing to people. So I say if that happens, to use that u, or whatever your favorite variable is, I'm going to use a u. See how that's the same thing? 4x cubed u to the 4th minus 12x to the 4th u squared. What would you factor out of here? What's the greatest common factor? 4. What else? X cubed u what? Squared. So if I do that, if I divide this by this, I'm just going to be left with u squared. If I divide this by this, I'm going to be left with 3x. So that would be how this would factor. And then I would have to check to see if this can factor down anymore, but it can't. So that's the same thing I'm going to do here. It's the same problem, but now these are u's. Instead of being u's, rather these are x plus 2. So I'm going to factor out a 4x cubed x plus 2 squared. See, same thing. What I have left then is x plus 2 squared minus this divided by this is just 3x. I have to have it completely factored. This is already factored. This is factored. This is not factored though, because I have to combine all of this first. See, this has to be combined, and then I have to see if I can factor it even further. So this is going to be x squared plus 4x plus 4 minus 3x. See, this is saying I have to square it and subtract 3x. This one is just a quantity squared. That's why I didn't have to do anything with it. But this one is squared minus 3x. So now I'm going to have 4x cubed, x plus 2 squared, x squared, 4x minus 3x is x, plus 4. And I would need to check if this can be factored further. Numbers that multiply to be 4, 4 and 1, 2 and 2, those go around to be 1, so it can't be factored anymore. So that's how I know I'm finished with it. Questions on that? Yeah. No, because then it's not factored. Because then it would be x squared plus 4x plus 4, and that can factor down to x plus 2 quantity squared. Now, if something was being subtracted from that, like if it was minus 2 or something, then I'd have to expand it, combine it with the 2, and try to factor it again. Anything else? Is that what you're going to ask? Okay. The reason we want things in factored form is because if I set it equal to 0, it's easy to solve now, right? If it's not in factored form, like if we go all the way back up here and I set this equal to 0, it's really difficult to solve that. But if it's in this kind of form, I know this has to be 0, this has to be 0, this has to be 0. It's very easy to solve. All right, last thing, this is just review. We've done this quite a bit. Right is a single radical expression. To have a single radical expression, we have to have the same roots. This is a 6th root, this is a 4th root. So I have to rewrite this in exponential form. This is x to the 5/6. This is 3 to the 1/4. If I want to have a common root, I need to have a common denominator. What's that common denominator going to be? 12. So this would be x to the 10/6, or 10/12, sorry. This would be 3 to the 3/12. So then I'm going to have the 12th root of x to the 10 times 3 to the 3rd. Well, I should write that as the 12th root of 3 to the 3rd is 27x to the 10. So this means the same thing as that.
What do you mean?
Because if I had to plug in a value for x, it's a little bit easier to do this. It's just another form. Anytime you do a problem in math, it's all about knowing an equivalent value to it that's all together as one expression. Like you can imagine if we had, 10 of these written out. If we could write it as just a single expression, it doesn't take nearly as much room. Same thing here, get a common root. A to the 2/6, B to the 3/6, C to the 5/6. Now we have that common root, that common denominator, so it's just going to be this. Okay. So these reviews that I'm giving you, these are actually even a little bit more difficult than your exam will be. So even though this seems kind of difficult, there won't be many this difficult on your exam. But it's good to be able to reach this depth, even though it's not as difficult as what we expect you to do on the exam. You need to be able to do it next year on your pre-calc for sure.
Okay, guys. So